Hello students, Miss Slyman here with 5.4 notes, and these notes I'm actually going to work out with you. And I do mean with you, so really pause and think about what's being said. I'm going to start, so we're now moving into the part of this unit where we're looking at geometry of circles and circle theorems. So theorem is something that has been proven to be true, and we use it a lot in mathematics, and so this is something that we take to be true. Ooh, let's spell true correctly. So it's a true proposition. Okay, and now let's look at our parts of the circle. So here's our center. You can spell it either with the British spelling or the English spelling, if you want to spell it or the American spelling with ER. So a radius, I hope you all know, comes from the center out to a point on the circumference. Circumference, of course, is the whole distance. Radius, we have plural, is radii, with two i's, fun. Sector is a portion of a circle that goes through the center, and it has two endpoints on the circumference. So either this bit here is a sector, or I could think of this whole portion also as a sector. So all of that can be a sector. Now, a segment and a chord do not involve the center. So a chord goes from 2 points on the circumference and does not go through the center. If a chord did go through the center, so this way, we would call it a diameter. So a chord goes through 2 points on the circumference, not through the center. A segment is formed from a chord, and an arc of the circle, again, not going through the center. So both of these do not include the center. So subtended, this word subtended means traced out. So right now, here we're talking about these angles. So this angle here is subtended at the center. It means it's traced out through the center. Here, subtended at the circumference, that angle is traced out through the circumference. It involves only points on the circumference. So subtended is traced out. So let's look at some of this stuff. So here's our first theorem. The angle subtended at the center of a circle is twice the angle subtended at the circumference. So what we're saying is that if this angle inside is x, so this angle subtended at the circumference, then the angle subtended at the center is twice the size of that. So that's twice x. I've decided that to help not confuse people, I'm going to do proofs on a separate video. So if you want to see the proof, then please come look at the next video I'm going to make. So see separate video. And otherwise, we're just going to take this theorem and go back with our definition of theorem is something that we take to be true. So if you believe me that that's true, that's Theorem One. Okay, angles subtended by an arc in the same segment of a circle are equal. So let's think about this. Angles subtended by an arc, so traced out by an arc. So if we look at one arc, so I'm going to go from this point to this point. Here's the arc. So angles traced out by that arc. So here's one angle. Here's another angle. And here's a third angle. So those angles are all subtended by that arc because they all share the same arc, are equal. So we're saying that this angle is equal to this angle is equal to this angle. So we can use our little line to show that all those angles are equal. We could have used a star. So here's Theorem 2. Again, the proof is a separate video. But right now, if you just believe me that those are equal to each other, then we can move on. Okay. Find the angle marked with the letters. So here we're looking for angle A. This is Theorem 1. So Theorem 1 says that angle O, so O is at the center, so angle O is equal to 2 times angle A. So angle O is 78 degrees. That's equal to 2 times angle A. So if I want to find angle A, I have to divide by 2, and I get 39 degrees for the measure of angle A, or the size of A. Okay, so now I want to find B. Well, I can see that B is traced out by this arc here. And then I can see that also this angle is traced out that way. So that means that angle B must be the same as the 31. So that's Theorem 2. So angle B must be equal to 31 degrees. Okay, our next one. Well, we're trying to find angle C here. Angle O is the center. So what does that tell us? Let me think about this. So we've got 73 from here to here. Can we somehow use, if we also went through the center? I don't know if we can use that or not. So I'm thinking about Theorem 1. That doesn't seem to help me. I know that this angle from here to here is going to be twice this angle from there to there. And does that help me any? This angle traced out to here. Oh, that does help me. Okay, so what I see is that right now, angle C, so 2 times angle C is going to be equal to angle O. So if I'm thinking about this as my angle O, and then I've got, is that going the right direction? Maybe that's not going the right direction. Let me think about this some more. So what I just went to think about was the Theorem 1. So Theorem 1, the nice thing about Theorem 1 is the way the picture is drawn. So the picture is drawn like this, and it comes down to here, and then I've got a center point that says, that comes from here to here. So then this angle, this is then twice that angle. But I've got the same bit subtended. So that's the problem with what we have right now. That what I was writing and what I was drawing is not the same. I knew there was something wrong there. Okay, so if I think about angle C being, angle C subtends this bit here. So that means that this angle, O, that now goes through the center, must be twice angle C. So this green bit inside here, down to here, must be 2C. Okay, now let's see how my 73 helps me. I know that 73, if I look at that angle, so I need to erase some of my lines because I've drawn quite a few lines on here. It's hard to see. Okay, so 2C is made to here. So 73 traces out here. So if I go from the center to there, that would be this bit. So this bit inside here is equal to 2 times 73, because the center angle is bigger than the outside angle. And I know that together, these must sum to 180 degrees because they make a straight line. So they make that straight line there. So let's work out our equation. 2C plus 146 equals 180. Subtract 146 from both sides. So 2C equals 34. C must be 17 degrees. And that makes sense looking at my picture as well, because C is very small. So here we used Theorem One twice, and we also used the fact that a straight line adds to 180. So this is angles in a line. And over here, both of these things were Theorem One. Okay, let's look at another one. So now I have angle D is what I'm looking for. So let's think about what we know. We know that this 58 degrees is, let's see what that traces out. Because looking at what it traces out makes me think about Theorem 2. So I see that 58 degrees is being traced out, but not from two things on the circumference. So what else can I think about? I've got 3 angles of a triangle make 180. And I feel like this angle must be the same. Oh, of course it must be the same. So think about why it's the same. Think about what we know about radii. So if I look at this triangle, I'm going to turn it to look like this. And here is my D on the top. So D is up here at the top. And I've got 58 down here. Well, I know that this side and this side are both radiuses, or radii. That means I've made an isosceles triangle. So this angle has to also be 58. And now I know that the 3 angles of a triangle, so D plus 58, make 180. So D is equal to 180 minus 116, because that's what 58 plus 58 is. Geez, 116. So D must be equal to 64 degrees. So don't forget the things we already know. Those are things we can assume to be true. So isosceles triangles, we know, have 2 sides the same, 2 angles the same. Okay, this one looks to be a very simple Theorem 1. So Theorem 1 says that angle E is 2 times 26. So angle E must be 52 degrees. Okay, this is a very complicated picture, so let's see what we can pull out. None of these bits are the center, so we don't know anything going through the center, but I can see that my 40-degree angle traced out goes from this arc over to this arc, and we have nothing else on top that goes through that. We have that 75 traces out, so let's erase that and look at 75. 75 traces out from here around to here, well, that's nice because from here around to here is also angle F. So we've got this being traced out, but also angle F on the inside traces that out. So that must mean that by theorem 2, angle F is equal to 75 degrees. I know that that means that this blue angle inside, so the blue angle is equal to, well, I know that blue angle, which I really should call a variable, let's go in and put a variable, let's call it x. So I know that f plus x plus 40 is 180. Well, I just said that f was 75. X plus 40 is 180. That's 115. So 180 minus 115, that is 65 degrees. And then I know that h is equal to x. So h equals x. So h is equal to 65 degrees. That comes from vertical angles, so those two angles up across from each other are equal. And then g must be equal, let's do g in black, g must be 180 minus 75 minus h, so 105 minus 65 gives us 30 degrees. Does that make sense? 30 and 65, that doesn't make sense. 40. Okay, so there we go, all our angles. And that sums up using theorems 1 and 2 of circle theorems. So go back and look at what those circle theorems are, and we'll work on solving problems with those in class. I'll see you there.